I am Dominique Collet, Technical Marketing and Application Manager at Heidelberg Instruments, and today I'm happy to present our very first user interview at EPFL CMi. L'École Polytechnique Fédérale de Lausanne, also known as EPFL, is one of Europe's most vibrant and cosmopolitan science and technology institutions. Its Center of MicroNanoTechnology, the CMi, was a beta site for our very first Maskless Aligner in 2014. We are happy to announce that they will soon receive their second MLA 150. To understand better about the CMi, the way it is run, its role within the EPFL, the research that it serves, and the industries that it supports, we invited Julien Dorsaz, the manager of the photolithography division of the CMi. Good morning, Julien.
Good morning.
Before working at Heidelberg Instruments as engineer in the Maskless Aligner department, Théophane Besson studied at EPFL. We thought that he was the right person to interview Julien. Good morning, Théophane.
Good morning.
Thanks to both of you for being with us this morning. So Théophane, you are free to start.
Thank you. Hi, Julien. Nice to be with you today. What is your background? And when did you start working at EPFL?
So first, good morning, Dominique. Good morning, Théophane. Thank you for the opportunity to let me discuss today. My name is Julien Dorsaz, so I am part of the photolithography staff. Regarding my background, I did studies and a PhD in physics at EPFL. Then I worked for two different companies in the field of optoelectronics, so mainly design, fabrication of LEDs and lasers. Since 2014, I am part of the photolithography staff in CMi, and I am responsible mainly for coating development and exposure processing equipment. So this includes direct laser writing tools.
With that background, what did you motivate you to come to CMi EPFL?
Working in CMi for me was a unique opportunity to combine my passion for research and development, but also to share my knowledge with others by teaching and training younger scientists. Also, you know, the EPFL is a very large international and multicultural community. So it's very exciting and stimulating to work there. And also you can see the scenery behind me. We have the lake, we have nice mountains. So this is also a plus.
Yes, it looks really nice. We've been talking about CMi, so can you clarify what the role of the CMi is within EPFL?
CMi is one of the core facilities at EPFL. Its missions can be summarized, I would say, in 4 key points. So first, we provide basic and advanced training on processes and technologies. We offer access to state-of-the-art processing equipment, which are available in the Cleanroom. We practice the most advanced know-how in the microtechnology field. And as much as possible, we try to cooperate with other academic institutions and research centers.
Okay, so what is the size of it? How many employees are working there with you?
Our clean room extends over 2 floors, and it covers a total area of about 1,500 square meters. It is managed by a staff of about 20 to 25 full-time employees.
As I understand, in Switzerland, there are many research centers that are also partly part of the Swiss research program like CSEM, PSI, ETH, or IBM. What is the relationship between those centers and the CMi?
So at EPFL, we have the chance to have a large international community. So we have many contacts both in Switzerland and around the world. So in most of the case, we try to collaborate, to exchange information and share experiences in the domain of microfabrication.
How is it financed?
So CMi is part of EPFL. EPFL is, as a school, is funded by the Swiss government, and the Swiss government will allocate the budget for the purchase of new equipment and as well as a new infrastructure. Now the operating costs of the CMi, mainly salaries, media, they are covered by the fees, which are paid by CMi members using our facility.
So is there also some revenue that could be generated by an industrial customer coming to your facility?
Yes, so both academic and industrial users can access the clean room. The pricing model will be slightly different depending if you come from the industry or from an EPFL laboratory. Industrial users will usually pay higher. Overall, in total, industrial users cover about 1/3 of the CMi revenue.
Okay. We've been talking a lot and seeing a lot in the news that the EU is investing massively in the semiconductor sector. Is Switzerland involved in this process?
Not much, I would say. You know, the semiconductor industry requires massive investments in order to stay competitive with the major competitors in US, Taiwan, and China. So Switzerland is a very small country, and we have a hard time to compete. So usually our industry is mostly focused on a niche market and not necessarily on the semiconductor market, apart from very specific research projects.
Can you still participate in the EU-founded projects?
We can, but the bilateral commercial relations between Switzerland and Europe are a little bit difficult, and they evolve regularly. Currently, researchers and companies from Switzerland can participate in European research projects, such as Horizon 2020. However, they will not receive any fundings. So this is kind of problematic. The Swiss Department for Economic Affairs will try basically to provide some compensations to the concerned researchers.
Okay, can you tell us more about the research conducted at CMi? Are they rather application-oriented, or do you also do fundamental research?
A little bit of both. So we are dedicated to microfabrication. So most of our users intend to fabricate functional devices, most generally in the prototyping phase. But on the other hand, we have some users which produces devices which are tools for more fundamental research. For instance, in microfluidics, they create cells and traps for biology studies.
And what are the main applications then that those users try to do?
We have more than 70 laboratories in accessing the clean room, and they come from different EPFL faculties, engineering, basic science, life sciences. So we have a very broad range of research topics. We can mention integrated photonics, power electronics, MEMS, and biology, so sensors, microfluidics. This is just a short list among others.
And are there links with private companies? Do they find inspiration with the research that is going on at CMi? And does it help to have such high-end infrastructures in the area?
It helps. So we have scientists here operating in CMi which are working on really new and innovative technologies. And they are trained and learned to operate state-of-the-art equipment. So when they leave EPFL, they have a very strong package and experience, which is attractive for private companies. So there are many companies usually that have a small satellite office in EPFL in the innovation park, and they look for and they hire new talents.
And also, does an academic clean room help the research and development of private companies?
We have private companies that are CMi members. So usually, as an academic institution, we study new technologies with advanced and innovative scientific equipment, and these equipment are in our clean room before moving to production facilities. So usually private companies can access the clean room to evaluate the potential of certain new technologies before purchasing the tools themselves.
Do you mainly see companies, Swiss companies, or are there also foreign companies coming to CMi?
Mainly, there are the Swiss companies. However, we have equipment which are very advanced, such as a deep UV lithography line, which attracts some international companies due to the very unique configuration. So we are still mainly based on 100 millimeter wafer size, and for some companies it's pretty specific, and they come to us from abroad.
What about startups? I guess that with all those students working in CMi, there must be a lot of startups growing from CMi. Do you have any examples you can share with us?
Yes, so we have, we are part of the school, so we try to have an attractive cost policy for EPFL laboratories. And there are many EPFL spin-offs that can access the clean room. So it's an ideal environment for them to develop their prototype. So over the year, several companies have designed their chips in CMi. One of the latest examples is Ligentech, spin-off of EPFL, active in the fields of photonic integrated circuits.
With the climate, we need to talk a little bit about the consequence of it and the awareness of climate change. Do you see that it influences the research that is done at CMi? Are there projects that try to address it?
So yeah, climate change is a hot topic, and it's clear that there are several EPFL laboratories that are focused on the energy transition, with the focus on renewable and sustainable sources of energy. This includes research on solar cells, hydrogen cells, synthesis and storage, biofuels. This is to name a few examples. Now, of course, CMi as a clean room, I would say it's not the most green-friendly environment, but we try to be cautious and to analyze the climate and the consequences when we invest in new equipment and new infrastructure.
Talking about equipment, can you describe a little bit the main equipments of the clean room?
Yes, so we try to offer a broad range of equipment that to cover all the needs for the production of micro devices. So this means mainly starting with photolithography, but then etching, thin film deposition. We also have some equipment for back-end processing, some characterization tools, but they are not the core of our equipment package.
We talked before that the clean room was shared by academic and industry users. How do they share? What are the proportions?
I would say we have about 70% of our users that come from EPFL laboratories. They are either PhD or doing postdoc research. 20% of our users come from Swiss companies and startups, and then the remaining 5, they come from international companies or international research institutions.
And how many users do you see per year?
About 600 different scientists are accessing the clean room every year. Sometimes just for a very small project, but some are coming very regularly. On a daily basis, we range from about 30 to 50 users in the clean room at peak time.
I guess that all those users need to know how to use the tools and to use the clean room facilities properly. How are they trained by your staff?
So we are a user lab, so we train the users and then they operate themselves. But the concept is when they join CMi, they have to submit a process flow which details every fabrication step they intend to perform. This is reviewed by us. We accept the process by also giving suggestions of which equipment and technology to use. Once this is accepted, they are trained by the staff on the specific equipment that they need. And after the training session, they are free to book the equipment and to work on their own.
Do you need to share equipments with other clean rooms?
As I said before, for microfabrication, we try to provide a complete and self-sufficient package of tools. Of course, people also need to characterize their devices, and we are not necessarily equipped for that. So we have collaborations with other facilities in EPFL, but also in other places. And we know which tool can be used to characterize certain types of devices. So we share when necessary.
So since we are a lithography company, I would like to ask you a few questions about it. How many users use laser lithography?
Over the last year, we had about 200 CMi users from about 40 different laboratories using our MLA 150 equipment. Since its installation in 2014, we have trained more than 400 users on the system. So this is one of our most active system, and basically every user has to do some photolithography at some point. We have a second equipment, a VPG 200, which also has similar statistics.
What type of resists do the user use?
They have very different needs, and consequently we offer a very broad range of photoresist. So there are the very thin, below 1 micron photoresist for high resolution applications, some thick resist for high aspect ratio. We also have solutions for lift-off processing. We have positive and negative photoresist. We also work with different type of chemistries, such as SU8.
What is the state? I mean, you must be trying to achieve better and better resolution. So what is the state of deep UV in the facilities? Would you see the need for a deep UV laser lithography sometime in the future?
We are lucky to own the deep UV stepper with an inline connection to a coating and development track. So this operates at 248 nanometer. And this is basically the state-of-the-art configuration at this node. So the printing performance is great. Resolution can go down to 150 nanometer with very good uniformity and high throughput. So in our case, we do not see the need for a deep UV laser writer. As you know, deep UV lithography, it has merits in terms of resolution, but it suffers from restrictions and limitations compared to the more mature and I would say the more versatile I-line photoresist and I-line processes. So,
and users that want to go even further can use the e-beam lithography. Do you use also the scanning probe lithography technology?
So we have an e-beam lithography equipment. We are planning to purchase a second one in the coming years. We do not have an nanofraser equipment in the CMI, but we have one installed in one of our partner laboratories, which is EPFL LMES1. They have used the system since 2017. And basically, in our case, we may collaborate on certain projects, and we follow the updates on the technology.
An actual topic with photolithography is also 3D printing of micro and nanostructures. What can you tell us about two-photon lithography at CMI?
We are equipped with one 3D laser writer based on two-photon absorption. They are really exciting equipment because it lets you print basically everything. We have a certain number of groups that are active on this equipment. They work mainly in the fields of micro-optics, micro-robotics, applied photonics, and microfluidics. And yes, the tool is used daily. It's kind of niche project because they are still a little bit slow in terms of printing time, but very exciting types of equipment.
Since the CMI has good collaboration with the industry, could you tell us more about what kind of industry adopted photolithographic process? Do they usually invest in their own equipment, or can they also come and use your facilities to produce?
So they can come and use our facilities. But as you know, our missions are mainly focused on research, development, and training. So we are still based on small wafer sizes, 100 millimeter. And we do not necessarily have the equipment for industrial scaling in terms of large wafer sizes, high throughput. So industrial partners, they come to our facilities to develop projects, but most of the time when they are happy with this, they have their own facilities for scaling.
How do you see the optical lithography evolving in the next 10 to 20 years?
So I think we already discussed a little bit about high resolution processes, so scanners, extreme UV. In terms of budget, this is completely out of reach for CMI. So I expect that the traditional 2D photolithography will remain the main photolithography method. And maybe still here in 20 years, together with e-beam lithography. This i-line photolithography technology is mature, the process are stable, equipments are mask aligners and laser writers. They are cheap and constantly improving, so they will stay.
What will be your needs then in terms of resolution, throughput, or are you even planning to go from 100 millimeter to 200 millimeter at some time?
It really depends on the needs of our users. So we have a selection of users that needs the high resolution, but we are some which are working, in hundreds of microns in terms of dimensions. So it's good to improve the resolution, to improve the uniformity, to reduce writing times, but maintaining the stability of the process is also very important for us. Since we have a very broad range of processes and photoresists.
Let's talk a little bit more about the MLA 150. About 8 years ago, we had a conversation to install a beta site of the first MLA 150 we produced at EPFL. And you believed in this idea and become the first owner of the tool. What made you believe and trust this new technology at the time?
We were already actually familiar with the tools from Heidelberg Instruments because we were already operating DWL 200. So we were already kind of familiar with laser writing. The introduction of spatial light modulators in the MLA, the DMD devices was a very exciting, I would say, innovation. In terms of writing speed, in terms of lineage roughness control. So for us, it was a major step forward, and it was really convincing to acquire this system.
And how was it perceived to have such a tool? What were the challenges?
In the initial stage, I would say the main challenge was to convince the users to swap. I mean, it was still perceived that these equipment were suffering from low writing speeds, but as soon as they swapped from the mask aligners, they also saw the advantages, and most of them they didn't look back at the mask aligners.
What are then exactly these advantages?
So I would say it's very convenient, it's very straightforward to use. And of course, the first advantage is that you can get rid of masks. So consequently, it's easy for you to change your layout. So for all the users which are in a prototyping phase, they can easily change the design for the next wafer. So this is just great. You don't need to waste time and money on the fabrication of masks. The second advantage is the flexibility in regard to sample sizes. So you can load the wafers of many different sizes without having to change the chucks, the mask size. Also for chips, it's extremely easy to expose small samples and chips. Finally, we can mention the alignment process, which is very simple. You have a high degree of freedom in the positioning of your marks, and the marks can be printed only in the first exposure step, which is really nice.
And soon you will receive a new MLA 150. Why did you decide to buy one more tool?
Mainly for two reasons. So MLA is today one of the most important equipment in our facility, and there are many users that daily use the machine for printing. We don't want to have downtime on this equipment, so it can really affect specific projects. So we wanted to have two of them. And also because the equipment is very popular, it's heavily booked. So having two of them in parallel can help and relieve the stress on the booking on these machines. and people we have more availability and to access the tool.
With this new MLR 150 and the old one, what will you be able to achieve that you couldn't really do before?
We have ordered additional options such as grayscale lithography and the new high aspect ratio module to expose thick resists. We are also going to upgrade the lasers for high power lasers to be able to print a little bit faster with certain configurations, mainly very thick SU8 layers. The rest is basically the same.
Thank you, Julien and Théophane. That was a really interesting interview. We have learned a lot on how the CMI works for students as well as for private companies. Its dedication to microfabrication and the way you are training the users is very inspiring. We are also very proud that our maskless aligner, the MLA 150, is intensively used and appreciated for its flexibility and intuitiveness. We wish you great work with the second one that is going to be in your lab very soon.
Definitely.
Thank you again, Julien and Théophane, and have a great rest of the day.
Thanks to both of you. Bye-bye.
Thank you.
Bye.
Bye.